Hi and welcome to the channel for the next video of Thermochemistry series. So in this video we are going to talk about the following learning objectives. Number one, what is the first chemical reaction that was done? A bit of history of chemical reactions. Number two, what are the common chemical reactions and what happens to the heat in these reactions? Number three, what is an exothermic reaction? And number four, what is an endothermic reaction? So let's quickly start with the first objective, guys, a bit of history of reactions. So the first reaction which mankind, the humans, did on this earth was fire. Why? Because it was a controlled reaction. We used to heat wood for cooking food, and we used to control the amount of heat we needed. If we needed more heat, we used to put more wood. So arguably, the first chemical reaction is fire in the history of human beings. However, the first chemical reaction done in laboratory was done in 1783 by Lavoisier. Lavoisier is also called the father of chemistry, guys. He reacted oxygen with inflammable air and he obtained a very pure state of water. Alright, now let's study some chemical reactions and see what is common in them in terms of heat. So there are two reactions. One is combustion of fuels like burning wood or coal for bukhur, charcoal. Two is explosion of a firecracker. So think for a second, guys, and pause the video and tell me what is common thing in these two reactions. Right, so I hope you have answered it correctly. The common thing between these two reactions is they both release huge amount of heat energy. So that brings us to the next learning objective, exothermic reactions. So the chemical reactions that release heat in their surroundings, they are called exothermic, guys. So it has been made in Greek. So in Greek, exo is for outwards and therm means heat. Thermikos, they call it in Greek. That means heat. So heat going out. So there are many such reactions we see. For example, neutralization reactions. When we put acid and base together, we get heat as an outcome. Aluminothermy reaction. And also there are processes in daily life that are exothermic. For example, respiration is a daily life process that releases energy to be used by cells. Similarly, guys, when we take example of condensation, steam, we have steam and that condenses to form water. So that steam actually loses energy. So condensation or conversion of steam into water is exothermic. Similarly, if we put some amount of water in a refrigerator, freezer, after some time it becomes ice. So why it becomes ice? Because the molecules of that water lose energy and they freeze together. So freezing is also exothermic. Alright, let's go to the next objective. What is endothermic reaction? So you can guess now, these are the reactions that take in heat. Endo means inside or inwards and therm means heat. So the reactions that take in heat energy, when they happen, they are called endothermic. Best real life example is photosynthesis. When plants do photosynthesis, they take in the energy of sun. Other examples of endothermic are photosynthesis, evaporating liquids. So when we have a liquid and we heat it, it becomes vapor. Why? Because it takes the energy from the gas and it forms the vapor. So that's endothermic. Other examples of endothermic are photosynthesis, evaporating liquid, and most of the decomposition reactions. Whenever we break down something, we have to give in energy. For example, if we have to break down water molecules into hydrogen and oxygen, we will have to take water in our apparatus and we have to pass electric current in it. So when we give energy of electricity, the water breaks down. So any breaking down reaction in chemistry, also called decomposition, is an endothermic reaction. Now let's understand what is an energy profile. So whenever we represent the energy flow of a reaction in a form of a graph, this graph is called energy profile, guys. Actually, energy profile is a graph in which the x-axis is the time progress of the reaction and the y-axis is the energy. Now, when we take an exothermic reaction, for example, when we react calcium oxide with water, this is an exothermic reaction. So when we draw the graph for this, this is how the graph looks like. So you can see the reactants, which is calcium oxide and water, are higher in the energy status or value, and the product, which is calcium hydroxide, is lower in the energy level. And then we make a peak, guys. So what is this peak actually? This peak represents activation energy. And the difference between the reactant and product height is called the enthalpy, or the heat of this process, heat change of this process. We will detail this enthalpy in our later videos. But for now, you should know these are the labels in the graph. So for endothermic reaction, let's take an example of calcium carbonate decomposing by heat. We call it thermal decomposition to form calcium oxide and carbon dioxide. So when we plot this reaction, guys, since this is an endothermic reaction, it takes in heat or energy. And that's why this time you will see the reactants are lower and the products are higher. Why? Because overall the reaction absorbs energy from the surrounding. Still, the peak of the reaction is activation energy, but this time the activation energy will be the complete arrow, right from the reactant till the peak. And a part of activation energy will become the enthalpy, which will be the difference between reactant and product.